Yeah, warehouse is nothing but a compute resource which provide the computing power in order to execute the queries and operations. We need to understand the type of warehouse and the size of warehouse and the environment that the warehouse works. It is a single cluster and multi-clustered warehouse. If you look here, we have two different types of warehouses in the Snowflake. Earlier, we have only standard warehouse, but over the while the period of going the Snowflake has introduced a Snowpark optimized. Actually, Snowpark optimized is a feature which got recently introduced around 6 months to 6 months back. Earlier, we have only a standard warehouse. See, basically, it's enough to have a standard warehouse suitable for majority of the use cases, other than if you are working in the use case which exclusively deals with a machine learning patterns like that, then we will go with this Snowflake optimized. Hope I mean to say when working in the ML environments like machine learning environments, exclusively we will deal with a lot of patterns, right? We will deal with the different algorithms like standard gradient. Standard gradient is a one type of algorithm. These type of complex algorithms, they require memory intensive. Memory intensive speaking that they need to the process of execution, right? Once the data get fetched from the database, actually to process the data must be kept on a RAM, random access memory. So when we in the memory intensive environment, the data is heavy. It cannot hold the data is heavy, so that the data which is kept on a RAM of a particular virtual warehouse is not sufficient. So in that case, the data will get spilled. I will let you know what do you mean by spilling while speaking about the query profiling. The data gets spilled either into the database layer or else a different layer. Okay, so we need to for that scenarios or cases we'll work with the Snowpark optimized. Usually for all the applications that we are using, I mean to say in the current market or current industry that we are using, standard warehouse is more than sufficient. That too, we don't go beyond for the size of a Excel. As far as I haven't worked more than a size of a double Excel in terms of warehouses. Till now, actually, I don't have a exposure of working in the machine learning environment. But actually, if you are using the machine learning, if you get an opportunity working on a machine learning environment, then we will use the Snowpark optimized warehouse. I will show you how to create the standard warehouse and how to create the Snowpark optimized warehouse. And one more difference is we have the starting size of we have the standard size. We have it usually. I will show you the sizes here. Hope you understand. We have two types of warehouses. One is a standard warehouse and Snowpark optimized. When we require the memory intensive, I mean to say here memory intensive speaks about to store more data on RAM on a executing compute node. Then we will go with the Snowpark optimized warehouse, or else you will work with the standard warehouse. These are the two types of warehouse that we have in a Snowflake. Then moving on to the sizes of warehouse. Actually, the size in Snowflake depends upon the size in Snowflake the size of warehouse depends upon the t-shirt sizing. Okay, as the t-shirt sizes starts from extra small, small, medium, large, XL, double XL, triple XL, 4XL, like that. It will go till 5XL and 6XL. Okay, if you if you pick a size of XL for the warehouse, then you have only one compute node. Okay, then if you are going to pick a size of S, then you will have two compute nodes. Here, it's if you are looking at a hexagon symbol, right? One hexagon speaks about one compute node. For our understanding, you can consider it as a one computer. Okay. If you pick the size of a Excel warehouse, XS warehouse, then you will have only one compute node to execute all your query, whatever the complex to execute all the queries that are performed by the concurrent users. Okay. Then if you have a warehouse size of S, you are going to have a two two compute nodes. If the size of warehouse is M, then you are going to have a 4. Like that, based upon the sizes of the warehouse, we are going to have the multiple compute nodes. If you have a 5XL, then you are going to have a, I mean to say, 256. Like that, it varies. Okay, this is about the virtual warehouse sizes. So basically we have a two types of warehouse. One is a normal warehouse and Snowpark optimized warehouses. Okay, if you can see here, these are the multiple different types of sizes: XS to S, M, L, XL, double XL. So if you are having to have a 6XL size of warehouse, then you are going to have a 512 compute nodes. These 5XL and double 6XL were only available with respect to the AWS regions. The two in US AWS regions. Currently, it supports only US government, Azure regions, and AWS regions. Okay, we don't have that 6XL and 5XL. We have till 4XL. We can create it as of now. Okay, if your environment is, if our Snowflake is hosted with Azure or AWS in US area, then we will go with a 5XL and 6XL. Okay, this is how the size varies from S to 6XL. Okay, you need to understand here actually what is the credits per hour. So if our warehouse executes, actually the billing in Snowflake is based on the credits. It doesn't consume based on the, so we will give certain amount of dollars and we will buy a credits per hour. Okay, so if you are going to if you are, if our excess, if our excess warehouse is running for 1 hour, then we're going to consume one credit. Okay, similarly if you are going to execute Excel warehouse for 1 hour, then it's going to consume 16 credits from our, from whatever the credits we buy from the Snowflake. Okay, it, I mean to say it, we will give certain, we will, let us consider that if one credit equal to 1 rupee, then we will give 100 rupees and we will buy 100 credits. The consumption is based upon, the consumption depends upon the warehouse size. If you are warehouse size and multi-cluster environment, let us consider if we are going to use two extra large warehouses for 2 hours, then it's going to consume 32 credits, 16 plus 16. This is how the billing will be happened in the Snowflake, and it's a per second billing. Let us consider if you are going to execute a, if extra small warehouse is executed for 61 seconds, then it will going to consume 0.003 into 61 seconds, 0.061 seconds. This is how the billing is charged. The minimum billing price for the Snowflake is 1 minute. So if you start a warehouse at 1 minute and execute for 40 seconds and turn off it, and if you start another again, if you start the same warehouse and execute for 60 seconds, you are going to have a billing for 120 seconds. This is how the credit consumption, and billing happens in the Snowflake. Okay, this is all about the virtual warehouse sizes. Then then moving on to the another parameter, like, see if you can Excel to, these are the virtual warehouse. If you can see here, virtual warehouses which are part of Snowflake, it start with a size M. Basically it's going to have a minimum, it don't have a Snowpark optimized size warehouses doesn't have a XS, S and L. Directly it will start with a, we need to pick with the size from M. And here M, if you can see, you need to notice one difference here. Here M, it has a 4. When it's a standard warehouse, you have a 4 compute nodes. When coming to the Snowpark optimized, we are going to have a 6 compute nodes for the M size virtual warehouse. Okay, this is the differences you need to observe compared to the Snowpark optimized and standard warehouses. Okay, hope everyone is clear till now. Actually, what do you mean by a warehouse and what do you mean by, we have a warehouse is nothing but a, in warehouse is nothing but a compute resources which is provided by a Snowflake to execute the queries. Okay, we need to understand, if you want to understand more detail about the Snowflake, we need to understand the type of warehouse, size of warehouse, and whether the environment is a multi-cluster or not clustered environment. We have a two different types of warehouses. One is a standard warehouse and another is a Snowpark optimized warehouse. Snowpark optimized warehouse only exclusively deals with the ML, ML kind of scenarios where which requires the high memory intensive workloads. Okay, it's usually standard is more suitable for useful for use cases of anything. It can be used for Snowpark optimized as well. But if you Snowpark optimized, it's as its size starts from M, it is used basically fixed for Snowpark optimized. Okay, then we have sizes of warehouse. The sizes are for the warehouse are given from a t-shirt sizing from XS to 6XL. This is what the differences between, I mean to say, different types of sizes we have. Any doubts till the size here? Please feel free to ask. Hope everyone is clear with respect to the type and sizes of warehouse. Okay, yeah. Can I move on? Anyone, any question? Yeah, thank you. I'm moving on to the next one. We need to understand here multi-cluster. See, we have environment like, see, let us consider we have a scenario where this is the this is, if you can remember here, this is the warehouse we have. We have the warehouse of a size S, and we have a queries that are giving up. Already these warehouses are executing these two warehouses are executing three queries which were fired by a same user or different users. When these three queries are getting executed, you can notice that again two queries have arrived for the execution. Okay, then what happens as the warehouse is busy executing performing the certain workloads, it will keep up in a queue. Then these kind, let us consider if you are working with the users with around 80 users which are working as concurrent users, and you don't have a clustered environment, and we have a two warehouses. Then there are a lot of queries that queue up, and till warehouse become free or idle. Okay, then in that particular scenario we will go with the multi-clustering environment, where we are going to group different types of different warehouses in a different sizes. Okay, we are going to cluster, we are going to create a cluster of warehouse, group of warehouses, where let us consider that here we have a group of cluster of three s size S size warehouses. Okay, if you know that S size warehouse contains the two two warehouses. Okay, as XS contains only single warehouse, S contains the two warehouse. Like that, if you are going to have a multi-clustered environment, then we are going to have a group of warehouses which are clustered. Here, whatever the queries that come in, automatically the load is getting based on the Snowflake internal mechanism. The load gets distributed among the different types of warehouses. Okay, now let's move on. When this scenario is useful means, let us consider great for the concurrent users. Actually, when different concurrent users, let us consider there are around 80 users. When 80 users file the different queries at the same time, then actually actually it will route to the different warehouses based on the whichever is getting free. Okay, it's not suitable for the complex workload. Let us consider, I will give an example as earlier. Okay, it's like multi-cluster environment is useful when we have concurrent users. Again, multi-clustered environment, we can term it as a scale out. Okay, for complex workloads, here you need to understand the complex workload. Complex workload, then we need to go with the scale up. I will explain you what I mean by scale up here. Okay, this is multi. Just understand that what you mean by multi-cluster environment. Multi-cluster environment is nothing but a grouping of warehouses. Why the scenario? Why you need to understand why the scenario we go when which scenario we go for the multi-clustering of warehouses. Assume we have only two warehouses here with a size S. Okay, actually these warehouses are executing three queries where it get occupied. There is no, it cannot move to the next queries which are in inline. It cannot execute the queries which already arrived, as it is already busy executing these queries. So in order to resolve this kind of scenario, we will go with the multi-cluster environment. In multi-cluster environment, we are going to group a different size of warehouses. I mean to say, with the same size, we are going to group a different size, different types of warehouses, and we are going to distribute the task among themselves. Okay, this will be the scenario. What is the advantage that we are going to get with a multi-cluster environment is we are going to have a we are going to we are it's useful for the concurrent users. Let us consider one complex query which is getting executed with the S warehouse. It does not give any results, but let us consider different concurrent users executing by a different queries. In that scenario, we are going to have an advantage with multi-clustering. Okay, in here, with respect to multi-clustering, we have two types of mode. One is the auto economy, if we'll discuss. One is a maximizer mode and auto scale mode. Okay, I will explain you what do you mean by a auto maximizer mode and auto scale mode. Hope everyone is clear with the multi-clustering. Why we are going with the multi-clustering. So if you want to create a warehouse, this is the once you log into the Snowflake, if you want to create a warehouse, go to admin. One second. On the left panel, you will see that admin, right? Click on warehouse. Okay. Now we have only compute underscore warehouse, which was provided by the Snowflake when we created the trial account. In order to create the virtual warehouse, just click on the warehouse. Okay. Give warehouse name. I'm giving as a testing. It as a creating first warehouse. Okay. If required, you can add a comment here. Okay. You need to select here. You need to select the type of warehouse, whether it's a standard warehouse or Snowpark optimized warehouse. It will speak to you about standard warehouse can be used most work. It is going to give some information where it can be used for most workloads. It can be used including for the Snowpark optimized as well. But exclusively if you feel that you are going to deal with a data which contains the patterns and algorithms, then which requires a large memory cache, then we will go with a memory incentive operations. Then we will go with a Snowpark optimized. As of now, standard is sufficient, so I will go with the standard. Then from here, we need to choose whether we require the size of warehouse like a extra small, medium, large, extra large. Okay. As of now, I feel that let's create the large warehouse. Okay. Here we have options of advanced options. Once you click on advanced options, it will show you whether the auto resume. Auto resume is the warehouse goes in. First let us understand auto suspend. Auto suspend in the sense the warehouse, it's like going into the keeping the laptop in the sleep mode. Auto suspend makes the warehouse to keep in a sleep mode after a specified period of time. Here we can define the suspend time here, number of minutes after. If the no query is getting fired or executed with respect to the warehouse, then the warehouse will go into the auto suspend mode after describing a certain number of minutes. Here the number of minutes need to be provided here. Then we have a auto resume mode. If you enable auto resume here, then automatically whenever the query is fired, there is no need to execute, there is no need to turn on exclusively the warehouse which is got suspended. If you are going to disable here, you need to exclusively turn on the warehouse. I mean turn on the warehouse to execute this query. Okay, now as of now I'm marking it as an auto resume. So here comes the multi-cluster environment. We need to understand that here the multi-cluster, whether are you going to create a only single warehouse with a size large, are you going to create a group of warehouses which are clustered together. Okay, then let us consider that I'm going to check this. It will ask for the minimum number of clusters and maximum number of clusters. If I give here the minimum number of clusters and maximum number of clusters equal to same, here I have given the minimum number of clusters and maximum number of clusters as same. Then we are going to create a warehouse which is a type of maximizer warehouse. Here, if you see here, maximizer warehouse comes under when the minimum number of clusters equal to maximum number of clusters, then it's going to be a maximizer mode. Okay, if I am going to vary minimum number of clusters and the maximum number of clusters, then it's going to be a auto scale mode. you need to understand here we have a we can create a two types of multi-cluster environmented warehouse. One is a maximizer clustered warehouse and another is a auto scale warehouse, auto scale clustered warehouse. When dealing with the maximized mode, here we are going to provide minimum number of clusters equal to maximum number of clusters. Both the we need to have the same number of minimum number of clusters and maximum number of clusters. Okay, if you are this is how we are going to create a we are going to create a multi-clustered environment maximizer mode. Maximizer mode is whenever we fire a query in the maximizer mode. This is the example here. If we are going to see a maximizer mode, whenever we fire a query, automatically that we are going to create that here. Here is example of 3 3. Yeah, here we have an example of three three maximizer mode clusters with a size s. Automatically, when irrespective of the queries number of queries you fire, automatically these three virtual missions will get started. This is what the maximizer mode is. And coming to the other than maximizer mode, we have another mode which is nothing but a auto scale. In order to provide the auto scale, we can define the minimum number of clusters and maximum number of clusters must be different. Okay, let us we can start with a 3 minimum number of clusters and we can go with a 9. Then it is going to be a auto scale. In auto scale mode, we have a two policies, which is a standard economy. We will discuss about the standard economy policy. Before that, you need to understand here in terms of auto scale policy, we can the minimum number of clusters can start from either 1 to 9. You can give any number. Okay, 1 to 9. If you are going to select one here, initially it will start with a one single warehouse get execute. Single warehouse here we are going to size of a large, right? One single warehouse will start, and depending upon the policy that we are going to choose, either the standard policy or economy policy, the additional warehouse get added based upon the load. The warehouses will be increased till size of I can create a maximum clusters till 10. Okay, initially it will be very difficult to take it, but it's a very easy and simple concept in the respect to the multi cluster and auto scale mode. Okay, just assume that in the auto scale mode, additional warehouses will get added. Okay, I'm going to explain the different types of policies about the standard policy and economy policy. currently i'm currently I'm taking the economy policy, as well. Economy policy reduces the it gives the importance for saving the credits other than the performance. Okay, there is another service, query acceleration service. I will explain this later. Actually, this is the recent concept that was introduced in a Snowflake, query acceleration. Okay, then I'm going to create a warehouse. So this is how our warehouse looks like. Okay, what are the warehouse that we have created? This is the warehouse that we got created. Okay, first once so coming back to here, we have a two. So far, I guess everyone is clear what. So far, everyone is clear what is a maximizer mode and auto scale mode and maximizer mode, right? When there is a when we are going to provide minimum number of clusters equal to maximum number of clusters, both are same, then it's a maximizer mode. If the minimum clusters and maximum clusters is not same, and then it's come to the auto scale mode. Okay, any doubts so far here? Actually, this is a damn sure interview question you are going to get it. If you have any doubts, please go ahead. Okay, hope no doubts, right? I'm continuing it. Okay, we have a when we pick the auto scale mode, we have a two different types of policies. I will explain you the two different type of policies. One is a economy policy and another is a standard policy. So just to show you documentation as well, in the maximizer mode is we are going to provide the same value for both the minimum and maximum number of clusters. Then we are going to have a maximizer mode. In terms of auto scale mode, we are going to have a different values. for minimum number of clusters. Okay, this is how. If you can see here, it automatically they have highlighted Snowflake start and stop clusters dynamically manage the warehouse. Okay, basically depending upon the workload, depending upon the loads on the warehouses, it automatically manages externally. We have two different types of scaling policies here. We need to understand it how this works. Okay, just I'm going. If you can see here, these types of two policies, when while we are going to create the warehouse, right, we are going to get show the two policies when we have the auto scale mode. Just I will show you that. In the multi-clustered environments, when we have an auto scale mode, then we are going to we need to select a scaling policy, whether the scaling policy is you are going to have a standard scaling policy or economy policy. The main if you can see here, if you can understand here, it will you can able to get it in terms of standard policy. If you are going to give a standard policy, Snowflake gives you importance for the performance. I mean to say, when the query is getting, if the query is getting filed, automatically it try to execute it. But whereas in the economy policy, without kicking on the new virtual warehouse, it will wait for certain period of time, as it gives a trade-off. It's like a trade-off between the performance and the cost. It will give more importance for the performance, for the quickness in the standard policy. Whereas in the economy policy, it will give you more importance for the saving of credits rather than the performance. Okay, these are the two policies that are available when you choose the auto scale mode. Let's discuss deep dive more into this different types of mode. If you have picked the standard policy here, standard policy, why the importance of standard policy, when you will go with the standard policy is actually it favors the more additional clusters over conserving credits. It gives importance for adding the virtual warehouse rather than conserving credits. Okay, basically whenever it notice the query is queued, the query got of when let us consider we have a auto scale mode, and three minimum clusters are three is running, and you can have a till 10 clusters. Let's consider the three clusters got occupied and another query got fired. Automatically, whenever the query get queued, when either the query is queued, the system detects whether the query is getting queued. Automatically, then the current running cluster can execute. It will automatically kick off the new virtual warehouse, and it will execute this query. But whereas in economy mode, it will take at least 60 minutes, 6 minutes. It will evaluate if whether the to evaluate that whether the current virtual warehouses are going to be busy till 6 minutes. Then only it considers the picking of or starting of the new warehouse. This is the main difference between the standard economy and standard and economy policy. If you want to conserve the credits, then you will go with the economy policy. It's if you are looking for the more additional clusters and more quickness, then you will go with the standard policy. This is the basic difference. Damn sure this is the one of the crucial interview question. Explain about the different modes in warehouse. I mean to say, whether it's a standard mode or standard mode or auto scale mode, and explain about the scaling policy, different scaling policies in the Snowflake. Okay, hope you understood this topic. What do you mean by maximizer mode and what is the auto scale mode? Understand one thing, only during the auto scale mode only we are going to define the policies, but not in terms of a maximizer mode. Okay, hope it's clear. Any doubts so far? What do you mean by warehouse and clustering environments? Okay, just recapping what we discussed here. We need to understand the warehouse. In terms of what do you mean by warehouse is nothing but it provides a compute resource to execute the Snowflake queries. Okay, if you one thing that must come to mind when discussing about the Snowflake warehouses is types of warehouse, sizes of warehouse, and multi-clustered environment. Type of warehouse, we have two types of warehouse. One is a standard, and there is a snowpark optimized warehouses. Okay, these when we going to work with a high memory intensive scenarios, then we will go with a Snowpark optimized warehouse. The standard warehouse, it's basically you can use it for any kind of use cases. Then we need to understand about the virtual warehouse sizes. The size for the warehouse is given with a t-shirt sizing from XS to 6XL, where XS small size warehouse contains only one compute node, and based upon the size of warehouse, the compute node varies. Okay, we have a Snowpark optimized warehouses which starts from M. Okay, and you can see here if you are going to select here from the virtual warehouse as a Snowpark optimized, you need to see here the virtual warehouse size, starting of the virtual warehouse size is M for the Snowpark optimized. Okay, that's the one of the main difference. And another is we need to understand multi-cluster environment. When we will go with the multi-cluster environment, in order to reduce the queries that are giving up for the execution, then we will go with the multi-cluster environment. In the multi-clustered environment, we are going to have a two types of mode. One is a maximizer mode and auto scale mode. One is a maximizer mode and auto scale mode. Maximizer mode, we are not going to define any kind of policy as every as all the clustered was all the as all the virtual machines which were clustered get kicked off in a single go. In terms of auto scale mode, we are going to have a policies which is either it's going to be a standard policy or economy policy. If you are going to conserve the credits, then we will go with the economy policy. If we are going to look from a performance perspective in order to avoid the queuing of queries, then we will go with the standard policy. It favors the additional warehouses. Okay, that's the main difference here in terms of standard policy and economy policy. This is all about the warehouse, and we have the scaling policies. Hope everyone is clear with respect to the virtual warehouse. While moving yesterday, we haven't discussed about the while discussing about the Snowflake architecture, we haven't discussed about the cloud services layer. That's I will explain the same. Yeah, this is the cloud service layer. The operations that takes place in the services that takes place here is services managed in the cloud services layer. These are the major services that it's going to take care in cloud service layer. Okay, it's going to authenticate whether it going to authenticate whether whoever is saying you are whether you are the was right person or not. It's going to perform the authentication. All the authentication issues were taken care by the cloud services layer. Then it's going to manage all the infrastructure, whether the whatever the infrastructure that we are going to utilize in the database service and query processing, virtual kicking of different virtual warehouse. If there is any issue with virtual warehouse, how we are going to rectify. All this going to happen internally with respect to the infrastructure management. It is going to taken care by cloud services, and it's again a metadata management. Metadata is nothing but a data about data. We will discuss about the metadata. What do you mean by we have a different types of caches like metadata cache, the local I mean to say virtual warehouse cache, result set cache. We have different types of caches. We will discuss about all the caches. Again, it's also one of the important interview question. What are the different types of caches available? And with exclusively with respect to the result set cache, excuse- exclusively with respect to the result set cache, what is the maximum period of days that it can retain the cache? These are the questions that will come under related to the cache. Then we have that query parsing optimization. This is the crucial, as we call it as a cloud services is no, layer is known as a brain of Snowflake, and the query processing layer is known as a muzzle of Snowflake. As it get executed, all the low workloads get executed in virtual query processing layer. It's known as a muzzle of Snowflake. As on behalf of us, when we fire a query on behalf of us, Snowflake is a very intelligent system. It takes care of lot of optimization and lot of parsing of query, lot of pruning of mecha. Internally, you need to understand the concept of pruning. Which we will discuss later in part of the sessions. Snowflake on behalf of us, it will take care of query, it will pick a query, and it will evaluate what is the best and easiest way that we are going to get data retrieved easily. It will evaluate and it will choose the best algorithm and it will fetch the data for us. So for that main reason, it's known as a brain of Snowflake. All this query optimization and query parsing is taken care of in the cloud services layer. And access control, let us consider every user who logs into Snowflake doesn't have access for everything which is present in the inside the Snowflake database. You need to have the it's actually it works with the rule based access control. You need to have a particular dedicated access to, you need to have a access gained for that objects in order to fetch the data. Okay, this is how the, this is all the services, this is what all the services that cloud services layer takes place. Okay, any doubts so far? We have discussed about the Snowflake architecture till now, from till yesterday, and we have completed only one topic of Snowflake architecture. Any doubts with respect to the Snowflake architecture or with respect to the virtual warehouse? If you have any doubts here so far, let's discuss that and let's continue it. Okay, hope everyone is clear right here. No doubts regarding the Snowflake architecture and virtual warehouses. Okay, we need to understand the different, before continuing, let's discuss about the different editions in Snowflake. We will complete that. Actually, I thought of discussing that earlier only. We have different types of editions in Snowflake. Okay, we have four different types of editions. One second. We have four different types of editions. One is a standard edition, enterprise edition, business critical, and virtual private cloud. Virtual private cloud offers a high level of security. Basically, it provides a dedicated cloud environment, dedicated virtual warehouse. No resources will be shared. Actually, it's a highly protected environment based on the US government agencies, like US government agencies, military agencies is going to work with the virtual private cloud, and it's going to be very costly. Okay, other than this, when you are working with the sensitive data with respect to the healthcare, personal information, credit card usages, then we'll go with the business critical environment. If for the general usage practice purpose, for the introductory level, in order to get explore more about the Snowflake and all, we will go with the standard edition. Usually, I mean to say, as per my experience based, if you are working with a sensitive data, then for the dev environments we will go with the enterprise environment. For the prod environments, we will go with the business critical environments. There are certain organizations even where the data in the dev also they want to keep secure, then they will go with the business critical environment. It's like having the, when it's like having different types of editions. If you go with the virtual private cloud, you are going to have a more premium level of features and everything. You are going to be isolated. Your data is not going to get shared with any of the different warehouses as well. This is going to be a highly secured environment with respect to the virtual private cloud. These are, there are a lot of differences. I mean, if you come to here, these are the, if you look at the standard edition, we have different. Standard edition doesn't support the, it will support the time. There have, we have a features like time travel and fail safe. I will explain you what you mean by time travel fail safe during the courses of time. Time travel, it will support only up to 1 day, the standard edition, whereas in enterprise edition we are going to have a 90 days of time period. Okay, it's like failback disaster recovery. We have the option disaster recovery in the business critical edition, whereas business disaster or business recovery feature is not available in the enterprise edition. It's like having the more features when you go to the later, when you go to the best premium version. Okay, it have, it's very simple that enterprise edition contains all the features of standard edition along with certain additional features. Material views are not supported in standard edition, whereas material views get supported with enterprise edition, like this. If you consider the business critical, all the features of enterprise edition is supported in business critical along with the additional new, like database failover and fail-safe recovery. If you take the virtual private cloud, all the features of business critical were supported, all business critical were supported, along with the new features like dedicated virtual servers. Okay, completely we are going to get a isolated environment with virtual private cloud, whereas all our all our resource get shared in all the, either it could, if you pick the standard enterprise or vertical business critical, it will share the virtual resource. Okay, this is how it works. Any doubts with respect to the different? If you want to if you want to more explore more about it, what are the basic, if you can open the documentation here, you can see there are a lot of differences. Here we have I have highlighted in slides, I have highlighted only few. If you can see here, these are the different. If you take SOC to type 2 certification, whether this type of certification is available, it is available in all the editions. Let's go with these are the different editions, right? These are they have highlighted. If you want to look at from a perspective of security, governance, and data protection, if you can scroll here, actually, customer managed encryption keys through Tri-Secret is one of the where you can add public key and private key. You can create your own private keys. It's you can combine both type of keys and you can create that Tri-Secure secure. This is available only in the business critical and virtual private cloud. You need to, if you want to look at any specific feature and want to check whether it's available in the any of the feature, then this is the right place to check. We have a lot of hundreds of features, like whether compute resource management. These are the different types of features in respect to interface tools. What are the features that get supported? Okay. With respect to the data sharing, if you can see here, this is the one of the crucial you need to understand here. When coming to the data sharing, if you can see here, no feature is supported with the virtual private Snowflake. VPS is the top edition, right? It's going to isolate all our data. If you can, the feature he's speaking here about is securely data share with other accounts. It's not possible with VPS environment. You cannot share any kind of data with VPS to business critical. Okay, this is what it is. It's a feature that was provided by a data sharing. Like that, you can evaluate multiple features. Okay, what are the types of support and what is the data pipelines that is going to support? The data pipelines, everything, streams are supported. Streams and tasks is another topic where we will work with the change data captures. Okay, how we are going to streams and tasks are supported by all the versions of the Snowflake. Yeah, this is the different types of editions that are available in the Snowflake. Okay, we have a different types of releases and everything. Tomorrow we will start with the different types of objects in Snowflake. What are the databases, tables, different types of tables? We will discuss more about the different types of tables. We have the permanent tables, temporary, transient tables. We will discuss about the different types of views. What is meant by a secure view and non-secure view? We will progress with the different types of Snowflake objects. Okay. Any doubts so far here? Any doubts or suggestions? Am I going a little bit fast or a little bit slow? Please let me know. I will try to adjust my pace.
Yeah, Mohan, you're going little fast. Okay, I want
Yeah,
we're quite slow. That's it.
sure, Raghu.
Yeah,
Actually,
yeah,
we haven't taken the sessions from the past 2 days, right? Actually, I thought of picking up. Sure, from tomorrow
yeah,
we'll
yeah,
go a little slow. Actually,
yeah. Okay, okay,
actually we
Mohan.
have a lot of syllabus, Raghu. Actually, the concern is we need to trying to cover in 1 month. We'll try to go a little bit slow from tomorrow. Okay. Thanks for
Yeah,
that.
yeah, 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 Mohan.
Thanks for letting me know. Actually, yeah.
Yeah, Mohan.
Thank you.
Where will get the records, Mohan, for this session?
Recording session, yeah. I will ask Amar will share
Yeah,
that.
yeah,
Amar will share that.
yeah, yeah.
Yeah. Any doubts? Yeah, other than that.
Okay.
Yeah. Raghu, any doubts with respect to the?
Yeah, I don't have any doubts.
Yeah.
Today is the clumsy is there. Yeah,
Sure, sure.
we have
Yeah.
to look into the video. Yeah,
Sure, Raghu. Yeah, please
that's it.
do that. Yeah. Sure.
Yeah, thank you.
Thank you. Any others? Any doubt? Yeah. Yeah. If there is no doubts, let's wrap the session for today. Tomorrow we'll kick off with the different objects in the Snowflake and we will discuss more about that. Have a great day ahead. Thank you all.
Yeah, thank you, Mohan. Bye.
Thank you. Good day. Bye.
Thank you, Mohan.
Thank you. Thank you.
Thank you.
Thank you.